Hi, my name is Danielle King. I'm a psychology major.
Hello, my name is Jordan Holmes. I'm also a psychology major, and today we're going to be breaking down a psychopharmacology article for you today titled
Investigation of Diazepam Efficacy on Anxiety-like Behavior in Hemi-Parkinson Rats. There is growing recognition that anxiety disorders have a greater impact on quality of life in Parkinson's disease than motor symptoms. Yet little is known about the pathophysiology underlying this non-motor symptom in Parkinson's disease, which poses a considerable barrier in developing effective treatment strategies.
The researchers administered diazepam to hemi-Parkinsonian and non-Parkinsonian rats and assessed the efficacy in 3 different anxiety behavioral tests. Overall, diazepam administration unmasked differences in anxiolytic efficacy between HA hemi-Parkinsonian rats, LA hemi-Parkinsonian rats, and non-Parkinsonian rats. The data suggests that neurocircuits involved in anxiety-like behavior may differ within these groups and posits that diazepam may have reduced efficacy in certain individuals with PD anxiety disorders. So Danielle, in your opinion, what exactly is this study researching?
That's a great question, Jordan. Thank you for asking.
You're welcome.
In this study, we learned that anxiety can affect 75% of Parkinson's disease patients. That's a lot. This study wanted to find a way to alleviate that anxiety by seeing how diazepam, an anxiolytic and benzo, would affect 3 different types of rats: the naive, sham, and Parkinson's rats. Native would be rats that were deemed to be healthy. Sham is a rat that had the same surgery as the Parkinson rats, but who were injected with saline. And the rats who were diagnosed with Parkinson's, they had degradation injected into them during the surgery. This study then conducted a series of tests to see how the diazepam affected these rats. So Jordan, now that we know what the study is about, what did you think about the results of the not surprising underdiagnosing and non-treatment of anxiety?
Well, as the study says, over 53% of Parkinson's disease patients remain undiagnosed and unmedicated in this situation.
Awful.
It is. Next, we'll be discussing the materials and methods part of our article, starting off with the model of Parkinson's disorder, which explains how each rat was made. A surgery was conducted on all rats, done by creating a lesion on the right side of the brain and boring a hole, which was injected with hydroxydopamine hydrobromide, which creates a degradation to the dopamine tract inside the brain. The exact same process was done to the sham rats, but they were injected with saline, which would have no degenerative effects. Next, there's the behavioral assay section of the methods and materials, which explains that for all behavioral assays, animals were transported to a separate red light room between 7 and 11 a.m. They were left to acclimate in the room for 1 hour prior to any testing, except for the locomotor activity, which was assessed under a white light.
Continuing on materials and methods, next was the locomotor activity, in which case the rats were placed in a cylinder, also known as the limb use asymmetry test, and they were counted how many times they touched the glass with either their right or with their left paw. This was very important for the research because this helps them know if the rats did in fact have Parkinson's disease. Since the right hemisphere of the brain was messed with in the surgery that was previously talked about, the rats that touched more with one paw, specifically with the right paw, were deemed to have Parkinson's disease. The next test that was done was the elevated plus maze, in which case, after the locomotor activity I just talked about, 2 days after, they were put in the middle of a wooden platform that was shaped like a plus, and they were allowed to explore their surroundings. There was a closed area and there was an open area. The rats were allowed to either cross into the closed area of the maze or the open area of the maze. If 4 paws crossed into either area, that was considered an entry, and obviously the rats that were high anxiety would go into the closed area, and the rats that were less anxiety would go into the open area. 2 days after the elevated plus maze test, they were put into an open field. They were then recorded and seen how many times those rats would go into the middle or if they would stay on the side. Based on the elevated plus maze, the researchers were allowed to kind of classify the rats as either high anxiety or low anxiety. The open field test allowed us to see if they were going to go into the open field or not into the open field. They were allowed to explore for a while, and they were videotaped, and they were seeing how many times they went back and forth. And that's how they knew how much anxiety
The
they
marble
had.
burying task was done after each of the previous tasks that we've discussed. It's important to note that each marble inside the cages was added with a drop of Tabasco to increase aversion to the marbles. What would happen is they'd put the rats inside these cages with non-glass marbles, and they were watching to see for either a latency in marble bearing, which means reduced marble bearing, or the amount of marble bearing they were doing. If marble was buried, it would have over 50% of it covered with the bottom covering of the cage. It's important to note that this was only done once after each rat was either injected with diazepam or saline to see the results. After all these tests were ran, the final test that was ran was the post-mortem analysis of these rats, in which case the rats were euthanized and then dissected, having their brains removed. Their brains were then cut in half and compared to each other, comparing the lesioned left side of the brain to the unlesioned right side of the brain to see the extent of dopaminergic cell body and axonal degradation within the brain. After going through the materials and methods with you, I have a question, Danielle. The locomotor activity in the materials and methods section mentions LAT and SNC. What do those terms mean, and why was this activity important for that research?
Well, that's a great question. It was a very important thing for the research. The LAT is the limb use asymmetry test. This test is used to see how many times each paw left or right would hit the glass cylinder the rat was placed in. In normal rats, there would be a 50-50 ratio of left and right paws hitting the glass. However, in hemiparkinsonian rats who had a degeneration of dopaminergic neurons in the right stratum would touch the glass more with their right paw, having a bias of 80%.
Wow.
Yeah, this touch bias was used to classify rats as hemiparkinsonian.
Okay.
What this means is that hemiparkinsonian rats, their right side of the brain was degraded, so most of their motor control in the left side of their body is inactive.
Okay.
The substantia nigra compacta, or the SNC as you asked about, is part of the dopamine system and was degraded, which we will talk about more when we get to figure 1. This activity was important because it allowed the researchers to classify rats as either having Parkinson's or not. So Jordan, earlier the elevated plus mage was mentioned. How does it work, and what information were they trying to gain from it?
Right, that's a great question, Danielle. It's a common assay used for assessing rodents. It's a plus-shaped piece of wood platform about 2.5 feet off the ground. 2 of the arms face each other, and the other 2 arms are closed, surrounded by an opaque wall. There was a central platform in the middle of the plus. They placed the rat in the middle, facing an open arm. Then the rats were allowed to explore for 5 minutes. They only counted an entry when all 4 paws went on an arm. The more time they spent in an open area, the less anxious they were. Anxious rats don't like open spaces. When they tested the rats when they were on the drug, it was done 15 minutes after they were injected with diazepam. This was only tested twice because the more trials the rats get on the elevated plus maze, the more comfortable the rats become with it. They would clean the maze extremely carefully so no scent was left behind. This was used to test how much anxiety the rats had before taking diazepam and after taking diazepam, and to test how much anxiety the rats had in general.
Interesting. Thank you for that explanation.
We'll now be moving on to the results section of our article. As you can see, we changed our background just a little bit, make it a bit more professional for the results section. So, for the most part, it was found that diazepam significantly impacted both the low anxiety sham rat and the low anxiety Parkinson's rat, as well as the high anxiety sham rat. But the diazepam did not show a significant effect on the high anxiety Parkinson's rat.
Interesting.
It is. We'll now be examining some of the important figures from the article that we found most relevant for what we're trying to explain to you guys, starting with Danielle's explanation of figure 3.
Yes, that's right. I found figure 3 was extremely helpful. This was the elevated plus maze example. When I was describing the study earlier, I said there were 3 different types of rats tested. In these results, we had both sham and Parkinson's disease rats. In addition to that, we had 2 different types of these rats, those with low and high anxiety. The research found that the diazepam injected was significantly effective in low anxiety sham, low anxiety Parkinson's, and high anxiety sham. However, it was not effective in the high anxiety Parkinson's disease. The Parkinson's disease rats have less entries and time in the open arm. It was also said that 60% of them had high anxiety. The sham had 40% high anxiety, and the native had little to none anxiety. So, Jordan, I was looking over the figures, and I saw that 4 and 5 seem to be very closely related. Would you mind explaining them?
I'd be happy to, Danielle, and you're absolutely right. The two are related.
Awesome.
In figure 4, which is related to low anxiety, the only significant difference recorded was the distance traveled in the open field while the rats were under the influence of the drug. The rats with Parkinson's traveled significantly less than those in the sham group, meaning their anxiety was not relieved enough to explore. For the other trials, there was no difference reported in the group. In figure 5, which is based on high anxiety, most of the differences seen were between sham and Parkinson's group, and there was no significant differences reported within a group. The latency goes up significantly in the high anxiety Parkinson's disorder, meaning diazepam doesn't have much of an effect in the open field test.
That's such a tragedy. I really wish it had.
Yeah, me too. And now I have a question for you, Danielle. Figure 1 seems to be important with the brain and how it affected which rats were diagnosed with Parkinson's disease. Could you please explain this figure?
I would love to explain this figure. Figure 1 shows 2 different pictures of a stained brain. If you're looking at it, you will see that both brains are very stained in the left hemisphere of the brain, while the right hemisphere has little to no staining of the dopamine tracts. This means that they have been degenerated to the point they would no longer pick up the dye. In figure C, this is quantifying the stained data in each individual animal and showing the percent depletion. We see there is more depletion in the SNC than in the stratum. This is because nerves project from the SNC to the stratum. If we look at part D, we will see a bar graph with the sham and the Parkinson's disease rats, and how many times their right paw touched the glass in the LAT described earlier. We will find that the rats diagnosed with Parkinson's disease touch the glass 80 to 90% more often than they would with.
Okay, I have a question for you now, Danielle. Figure 1 seems to be important with the brain and how it affected which rats were diagnosed with Parkinson's disease. Could you please explain this figure a little more in detail for us?
I would love to explain this figure. You're totally right. It does seem to be important with the brain. Figure 1 shows 2 different pictures of a stained brain. If you're looking at it, you will see both brains are very stained in the left hemisphere of the brain, while the right hemisphere has little to no staining of the dopamine tracts. This means that they have been degenerated to the point they would no longer pick up the dye. In figure C, this is quantifying the staining data in each individual animal and showing the percent depletion. We see there is more depletion in the SNC than in the stratum. This is because nerves project from the SNC to the stratum. If we look at part D, we will see a bar graph with the sham and Parkinson's disease rats, and how many times their right paw touched the glass in the LAT described earlier. We will find the rats diagnosed with Parkinson's disease touch the glass 80 to 90% more with their right paw than a sham rat, which would have an equal 50-50 with both right and left paws. This means that since the right side of the PD's rat's brain was degraded so much, the left paw would not move as well as the right paw.
We'll now be moving on to the discussion section of our article. The discussion section highlighted that hemiparkinsonian rats have a higher baseline anxiety-like behavior than the native or the sham rats. They also found that the vast majority of hemiparkinsonian rats have high anxiety as opposed to low anxiety.
Interesting.
Yes.
Lastly, it's important to note that...
We'll now be moving on to the discussion section of our article, which highlighted that hemiparkinsonian rats have higher baseline anxiety-like behavior than the native or the sham rats. They also found that the vast majority of hemiparkinsonian rats have high anxiety as opposed to low anxiety.
That's an interesting find. Finally, an important consideration in the study is that all of the tests that were used to assay anxiety-like behavior rely on motor function. Therefore, it is plausible that baseline anxiety-like behavior and diazepam efficacy could be affected by impaired locomotion in hemiparkinsonian rats. So Jordan, I was scrolling through the discussion section and I saw figure 6. I was kind of confused on what it meant. Would you explain it for me?
I'd be happy to explain it, Danielle. Starting off, A, B, and C are all looking at the striatal depletion of dopaminergic neurons, while D, E, and F are all looking at the substantia nigra compacta, which has a high quantity of dopaminergic neurons, both of which have been known to be impacted in Parkinson's. Striatal is the hub of the basal ganglia circuitry that impacts goal-directed actions and habits. These neurons project into other parts of the brain. The motor disabilities are caused by the substantia nigra compacta. The striatum gets input from the SNC, so there is a direct connection between these anatomic regions in the brain that are impacted in Parkinson's. Looking at figure 6C, the more depletion of striatal depletion and less distance they travel. As you have a greater depletion, they are going to move less. It means their Parkinson's is more advanced. We also see this in figure 6F, where the more depleted substantia nigra compacta is resulting in less movement. In B and E, where they are looking at anxiety, as the neurons are depleted, there are fewer closed arm entries. They're also probably moving a lot less because they're scared and alone. In A and D is how many times they do the forepaw touch in a cylinder. This data shows that a higher number have less motor control than they have on the left side of their body, meaning there's more Parkinson's disorder.
Thank you for that explanation. That
And
made
I
a
have a
lot of
question
sense.
for you, Danielle. In the study, it said that there were more high anxiety rats with Parkinson's disease than in the sham and naive. Could you give us some insight on that, please?
I would love to give some insight on that. This is actually quite simple. It means that the rats with Parkinson's disease suffered from higher anxiety levels than the other two types of rat. We can attribute this to the nature of the disease itself.
So, Danielle, if I was to ask you to conclude everything we had figured out from this article, what would you say to me?
Well, in conclusion, this article found that diazepam was not an effective drug to treat anxiety and Parkinson's disease. As we saw earlier, the high anxiety Parkinson's disease rats were not alleviated by the diazepam. So unfortunately, there would be more research required to find what drug could work in humans.
So you're saying this would be a improper approach to helping humans would be applying diazepam in a prescription set.
I would say that. I think that it would be helpful to find a way to do this, and I think the research actual process was really good, and the assays they used was very effective, but I think that we need to try a different drug.
Just didn't manage to get the results we were looking for, huh?
Exactly.
Happens.
So, Jordan, if this experiment were to be run again, would you change anything? And if you would, why?
I would change a few things, and I'll explain to you how. I personally think the mechanics of this experiment were very well thought out, and the assays that they used clearly showed the results that they found. I wonder if anything would change if we tried diazepam with another animal model. It is possible that the results they got were only because the rats reacted differently to diazepam. So I would like to see how it would affect the results, if at all, on a different animal. I think it would also be interesting to research other anxiolytics, including barbs, benzos, and Z drugs. I hope we can find a way to alleviate anxiety in rats with Parkinson's so we can find a way to cure humans from suffering from this disease.
That's a really good answer. Thank you for that.
My question to you, Danielle, would be, do you think diazepam would be an effective drug for treating Parkinson's? If not, what do you think would be the next drug to test out?
Well, Jordan, I don't really think diazepam would be a really effective drug for treating Parkinson's disease. As we saw in the study, it was not effective in the rats, so that would be a problem because we would want both low and high anxiety patients to be helped. I think an interesting drug to test out would be alprazolam, Xanax, and a slow-acting anxiolytic, which is very different from diazepam, a fast-acting anxiolytic. It would also be interesting to see how barbs would affect the rats with low and high anxiety Parkinson's disease.
It would be interesting.
So, Jordan, do you think that topics that we talked about in class helped us understand this article?
I certainly do, Danielle. It was actually quite easy for us to interpret the results of this article because we've previously been taught about the different effects of certain anxiolytics on the brain. Although results did not come out as the researchers would have hoped, I'm confident that there is a different anxiolytic which will yield the desired effect on Parkinson's disease the researchers were looking for.
I agree. I think that will happen. Unfortunately, this is going to be the end of our podcast. Thank you for listening. I really hope that we helped you understand diazepam and hemiparkinsonian rats.
I'd like to thank everybody out there for listening, and if you have any further questions, you can feel free to contact me or Danielle in the classroom, and I'd just like to thank Professor Ramos for providing us with the article and the information required to interpret it.
I definitely agree. Bye!
Bye.